Hey guys, so today's lesson is lesson 10.6. This is finding the area of regular polygons. So in the lessons that we did previously, we learned how to find the area of a triangle. So here we're going to find the area of a regular polygon by dividing it into congruent triangles. So first off, what is a polygon? A polygon is a plane figure with at least three straight sides and angles. Let me get my camera right. Alright, and then we have what is a regular polygon. So a regular polygon is a polygon in which all sides have the same length and all angles have the same measure. So here we have some examples of some regular polygons. The equilateral triangle, a square, a regular pentagon, whereas all the sides are the same, the regular hexagon, a regular heptagon, a regular octagon, a nonagon, and a decagon. So those are some of the ones that we'll be working with today. So the way that we're going to go about finding the area of this regular pentagon, this is a regular pentagon, is we're going to draw line segments from the center to each vertex. So if I draw line segments from the center to each vertex, the vertex is when right here where these two lines meet. That's not a very straight line, but there we go. Okay, so when we're looking at this, these triangles are all congruent. Same shape, same size. Okay, so to figure out, for the first step in this, or the second step, we've drawn the lines from the center of each regular polygon to the vertex. Now we're going to find the area of one triangle. So we're going to take what we know about this triangle right here. So we're going to use our formula. Area equals half base times height. So we're saying half of 20 times 14. So here, half of 20 is 10, so this is how I got this. And then bring down times 14, so 10 times 14 gives me 140. Now that's not the entire answer. That just takes care of one triangle. So to get the area for the whole polygon, I'd have to count the triangles. So there's 1, 2, 3, 4, 5 triangles. So I'm going to take the 140 and multiply it by 5, which gives me 700. So the area of this regular polygon is 700 centimeters squared. Now, going back up here, a polygon is a plane figure with at least three straight sides. A regular polygon is when all the sides have the same length. It's possible to have a triangle that's not an equilateral, that doesn't have the same length on all sides, or a pentagon that doesn't have the same. So the key word you're looking for here is, for triangles, the word equilateral, but for these other shapes is if it says a regular pentagon. That's your clue that all these sides are the same. So what we're doing here works for regular polygons. So we find the area of one triangle, and then we basically are just counting our sides, 1, 2, 3, 4, 5, or 5 triangles. So once we find the area of one triangle, we multiply it by the number of triangles there are to get our area. Alright, so let's look at the next one. Okay, so now we have a regular hexagon. We're going to draw line segments again from the center to the vertex, each vertex. Okay, so I have 6 triangles there. So to begin with, I'm going to find the area of one triangle. So I'm going to use what they give me for the base and the height here. So area equals half base times height. So I'm saying area equals half of the base is 4.2, and the height is 3.6. So I'm going to say half of 4.2 which is 2.1. I just take 4.2 and divide by 2, and that gives me half. And then I multiply it times 3.6. So I'm going to go ahead and use my calculator here. 2.1 times 3.6 gives me 7.56 meters squared. Now this is just for one triangle though. And if we look at this, this has 1, 2, 3, 4, 5, 6 triangles. So to get the area of my hexagon, I'm going to take that 7.56 and multiply it by 6 to get 45.36 meters squared. Alright, so next we're finding the area of this regular polygon. So we have 1, 2, 3, 4, 5, 6, 7, 8 sides. So because this has 8 sides, this is a regular octagon. Remember, these are regular polygons, so we know all the sides are the same here. So the number of triangles we'd have, since there's 8 sides, that means there are 8 triangles. Now you could go through and you could draw lines to each vertex to see that you would still get 8 triangles, or you can count the sides to see how many triangles you'd get. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Alright, so first we're going to find the area of one triangle. So we're going to say half of 5 times 6. So half of 5 is 2.5. And 2.5 times 6 is 15. So one triangle is 15 centimeters squared. So now we're going to take that 15 and multiply it by the number of triangles to get 120 centimeters squared. Alright, let's go on to number 2. So I can see that there's, instead of drawing, well no, I'll go ahead and do that. So we're drawing from the center to each vertex to see how many triangles I've got here. And that's going to be 1, 2, 3, 4, 5 triangles. This is a whole triangle. That line's just showing me the height. So see how it's dotted? Alright, so first I've got 5 triangles. I'm going to find the area of the triangle that they give me information for first. So half of 6 times 4. Then half of 6 is 3. And 3 times 4 is 12 meters squared. Now remember, that only takes care of that one triangle. But there's a total of 5 triangles here. So then I take that 12 and multiply by 5 to get 60 meters squared. Alright, number 3. It kind of gets to the point it's hard to keep count. So I'm just going to start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is a regular decagon. It's got 10 triangles. So first, let's find the area of one triangle. So we're saying half of 8 times 12. Half of 8 is 4. And 4 times 12 is 48. So that takes care of that one little triangle. Now I got to take care of the whole thing. So I'm going to take that 48 and multiply it by 10, because there's 10 triangles, to get 480, and that would be millimeters squared. Okay, number 4. This time we've got 6. So this is a hexagon. So I'm going to find the area of this one triangle first. So we're saying half of, and I haven't been writing my formula each time, which I should, but remember your formula is always area equals half of base times height. So we're saying half of 8 times 7, because that's area equals half of base times height. So half of 8 is 4, and 4 times 7 is 28. So that takes care of that one triangle. So now I'm going to multiply it by 6 to take care of the entire polygon. So 28 times 6 gives me 168, and that's centimeters squared. Alright, so the next one, again, I'm using area equals half base times height. So I'm going to go ahead and fill in my numbers. So we're saying half of 28 times 43. Half of 28 is 14. And then 14 times 43 is 602. So now I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is a decagon. So I'm going to multiply that by 10, which gives me 6,020, and that is inches squared. Alright, and the last one on this page, number 6, we have a regular pentagon is divided into congruent triangles by drawing a line segment from each vertex to the center. Each triangle has an area of 24 centimeters squared. What is the area of the pentagon? So I'm going to try my best to draw a pentagon just to have a visual. Now whether or not it's a regular pentagon, it may not look that way, but let's pretend it is. So they're telling me that the area right here is 24 centimeters squared. So what that means is I don't even have to find the area of that triangle because they've already given it to me. Because right here it tells me the area of that one triangle. So I'm going to take that area and I'm going to multiply it by the number of sides, or the number of triangles that are in a pentagon. And a pentagon has 5 sides, which means it has 5 triangles. So we're going to say 24 times 5, which gives me 120 centimeters squared for the entire regular pentagon. Alright, make sure that you are checking into Google Classroom for pages to go along with this to help you. I hope you don't have any problems with it, but if you do, please feel free to contact me through class tag, remind, my email, or Zoom. Have a good day.